Deriving the number of allowed electromagnetic waves in the frequency interval of d nu, we have drawn this diagram. This is the y-axis, x-axis and z-axis, and in this direction there is the electromagnetic wave propagating. This is a full wave shown here, and there is two node lies in the whole wave, that is, and we have divided it into lambda by 2, and the electromagnetic wave has made an angle alpha with x-axis, beta with y-axis, and gamma with z-axis, and we have shown the projection in x, y and z axis respectively. And now we will see this relation is very simple. We know lambda x by 2, we have written lambda x by 2, lambda y by 2, lambda z by 2 in terms of lambda and the projection angle. So ultimately we get these two relations, the displacement of the electromagnetic projection of the displacement of electromagnetic wave in the three axes, and we have written in terms of the lambda x, lambda y and lambda z, and this is displacement is x, y and z in all the three axes. So from here we will just some simple calculation is needed. Okay, first before the calculation we will, as we had seen in the one dimensional case, that is for 2x by lambda we had this n, for x equals a, for boundary condition we had this condition, and here for a in all the directions, for all the three lambdas, that is lambda x, and for the other lambda, that is lambda y and lambda z by lambda z, we have drawn three separate number axes. Those are nx, ny and nz, and now we will write this lambda x, lambda y and lambda z in terms of lambda. Those are, now this three equation will become 2a by lambda into cos alpha equals nx, 2a by lambda cos beta is equal to ny, and 2a by lambda into cos gamma equal nz. So now from here we can derive 2a by lambda whole square cos alpha square plus cos beta square plus cos gamma equals nx square plus ny square plus nz square. We know this term is equals to 1, so 2a by lambda square is simply 2a by lambda is simply ny square plus nz square. So here, as in the case of is one dimensional number axis, we had calculated the number of allowed frequency between two distinct point here. This is the d nu, and we had calculated the number of waves, number of allowed electromagnetic waves in this frequency range. So what it becomes in a three-dimensional world. So here, instead of number axis to one-dimensional number axis, there is three-dimensional cube. So one cube upon another cube, there will be another cube here also. So there is a grid of cube going out in all the directions. In the positive direction only. Till now we have got this relation 2a by lambda equals nx square plus ny square plus nz square, and we can write it in terms of frequency. There is, we can write as frequency equals c by twice a nx square plus ny square nz square. So as I've already mentioned, there is a lot some cubes going out in all the directions in the three-dimensional plane. Okay, so it is means for convenience we would like to convert this whole equation in a polar form so that the calculation becomes easier. So we this is nothing that like in the all the three axes there is a coordinate of a single point can be written as n, y and z. So the distance from the origin will be nx square plus nz square plus ny square. So this is nothing but the radial vector. So this whole term become nu equals c by twice a r. So from the simple mathematics we can calculate the number lies between this frequency interval del nu. So this is nothing if we like this cubes are going out in all directions. So if we consider a circle with its center coinciding with this cube, so the number of points in this range will be nothing but so that is the NRDR, that is the number of points lying between this range dr. That is nothing the number of allowed frequency that we are going to calculate. This is in terms of r, that will be later converted in terms of nu. So this is nothing but the this term will be equal to the density into volume, but here the density is 1, so simply equals to volume. Volume is nothing but 4 pi r square dr. But here is a term missing, that will be 1 by 8, because each point in the lattice, three-dimensional lattice, is like there is a point, okay, that is shared by 1, 2, 3 and 4 in there 2, and in the lower plane there is again there are 4 lattice, so it is shared by 8, total number of 8 lattice. So for each point it has to be divided by a factor of 8. Now we will convert this NDR to we will consider change the value variable, that will be nu. So like this then in terms of r, like we had already calculated that r is equals to nu into twice a divided by c. Square is term is there, 4 pi by 8 times already there. Dr will be like nu as c by twice a, so dr will be nothing twice a by c d nu equals dr. So what will we get is like 4 pi terms will be there again, 4 nu square c twice a by c like pi by 2 there will be 2a, so there is a terms also, 2a by c. There must be, okay, it was square, it will be cube, then nu square terms is there, and d nu. So we have derived the number of allowed frequency in the frequency range There is pi by 2 twice a by. Why were we doing all these things? Now it comes to question. So we are calculating the number of allowed frequency waves in this given frequency range, just to calculate the energy. That is, we have already given the terms that describes the energy. Those are radial frequency, spectral radiancy and radiancy. So from this term we have to derive the radial frequency. Okay, here comes a basic physical law, that is law of equipartition of energy. What does law of equipartition of energy says? Of energy. Law of equipartition of energy says that for any system, it can be any system. Here we have got the system of some standing waves. It can be any system actually. For any system, if the system can be described with some some degrees of freedom. The degrees of freedom is that the number of independent variable needed to describe the system. If there is a 3 independent variable, then total energy will be this term. So kT by 2 is the energy associated with each independent term. What is K and T? K is the Boltzmann constant, T is the absolute temperature of the system, and value of the K is 1.38 into the power minus 23 joule per Kelvin. Okay, that's it. So like in our system there was a number of standing waves. So each standing wave is a independent system. It is independent system that is degrees of freedom, means they are independent variable, independent system that is used to describe the whole system. So basically we can say that each standing wave is carrying an energy of this term. So we will get that energy flux, that is a variable of mu, that is frequency. What we have got is 8 pi mu square by c cube. There was a term a cube, but we are considering energy density, so a cube then cancels out. So there is a term d nu, and it is multiplied by kt. So it was 4. No, it was more 16 by 2. So we get the final expression as 8 pi mu square kt by c cube d nu. This is called a Rayleigh-Jeans formula. Formula of Blackbody radiation. So we will like to see how it matches with the actual practical result. So if we assume that this is the practical curve, but the function we have described will match very well in the lower frequency, but it will go to higher and higher frequency. It will go high and high for higher frequency. It was rho t mu. So it was describing pretty much good for the lower frequency, but it is not matching with the practical result for higher frequency. So it is called ultraviolet catastrophe, as the frequency of ultraviolet ray is very much high. So in the ultraviolet ray frequency range, the theoretical and the practical results are not matching, so it is called ultraviolet frequency for historical reason. So at this term, Planck came and he gave his own theory, which led us to his discovery and his own his own formula for rho t, which matches perfectly with the practical result. We will consider calculate that in the next video.